I want to introduce you to the concept of naming symbols according to their applicable parts of speech. There are exceptions to these rules, but not often. Most of the time, these logical guidelines will help you write code which is more self-documenting, descriptive, readable, and therefore maintainable without much effort. Let's have a look at the breakdown of this concept. You can see that we have three basic parts of speech: the nouns, the adjectives, and the verbs. As we look at the different elements of our code, we see that it makes a lot of sense that each kind should be consistently named according to one of these parts of speech. In this table, you can see how each kind of element is classified by its part of speech. Enum members are a bit of an exception as they can span several categories. There may be other rare exceptions too, but for the most part you can rely on these classifications. I think it makes the most sense to start by looking at verbs. We can see that verbs, of course, being a part of speech that describe an action. Functions and methods are what represents an action or an imperative in code, and so functions and methods should have names that are verbs, something that indicates an action, such as run or start or stop. Given that, everything else should probably be a noun or an adjective. A noun, of course, is a word that represents a person, place, or thing. We can see that pretty much everything will be a noun, with the exception of booleans. So we specify here that the variables, properties, fields, and parameters, which are nouns, would only be non-boolean variables, properties, fields, and parameters. If they're boolean, they'll end up being adjectives, and we'll discuss those next and show some examples. So as we look at the adjectives, we see that we're dealing with everything that would normally be a noun, except that these are all booleans, and of course any functions which return a boolean. As you'll recall from Mrs. Squatter Newton's third grade English lessons, an adjective is a word that describes a noun. Now, these syntactic elements need not be named strictly adjectives in the linguistic sense. You can be pretty flexible here. If you have a word that is potentially both a noun and adjective, or even maybe a verb, such as the word debug or debugging, you can flash around the word is or has to distinguish it as an adjective. The important thing is that it's a word or set of words that is descriptive of an implied noun. For example, the word active is a real adjective which describes some implicit noun, such as the this object, for example, but you may deviate and use the name has errors. Strictly speaking, has is a verb. However, there really is no ambiguity here, which would lead the reader to think that the name has errors would be an imperative, such as a function or procedure. It's obviously a specific attribute of some noun, such as the this object. Here we have a sample program. I've kept it simple and created one class with an interface. We see the interface before us. Its name is a noun, as we saw in the classification table. We've named it Data Store. Remember that a noun is a person, place, or thing, and our chosen name Data Store is a thing, so that's appropriate. Moving on, let's look at the members. First we have a Boolean property which we've named connected. Connected is a word that describes the state of the current object, the data store. This is a Boolean property and its name is an adjective, so that's appropriate. Next we have the connect method. I wanted to talk about this one specifically because it's a big exception. The classification table says that a function which returns Boolean should have an adjective name. We violate that here. The exception goes ahead because Boolean is particularly adept at representing success or failure, such as the result of an imperative operation. In such a case, this method name can be a noun. An example of where a Boolean returning function should be named an adjective is where its primary purpose is to return that Boolean value rather than to execute an imperative. For example, a function whose primary purpose is to determine whether a user is in a certain role would have an adjective name such as is in role. Again, it's a verb in its preposition. Is a verb, in is a preposition, and role is a noun. But overall, the phrase is in role describes the state of the this object, so it fits the adjective category. Next is a void imperative function. It definitely gets a verb name. In this case, it's named update email address. Same thing with the disconnect method below, but update email address takes a parameter. Remember where we classify parameters, just like variables, fields, and properties, this will be a noun unless it's a Boolean. Here we have a string, so the parameter name will be a noun. We call it email address. Now, as an aside, I want to offer a public service announcement that the word email is stupendously overloaded. The word email really refers to an email system, but we use the word to refer to an email system, an email message, an email address, etc. Please never use the word email unless you're referring to the conceptual system. If you mean email message or email address, please explicitly disambiguate as such. Thank you. And finally, we have a non-boolean property accessor, although I've mistakenly left out the property itself, getConnectionState. This is also a non-boolean function, so it gets the same treatment. This will be an adjective. We can usually disregard the words get and set in our determination of whether it's a suitable adjective or not, because these are typical of property accessors and are mostly found on methods which are not imperative, but actually just property accessors. So they can therefore be treated like properties or non-imperative functions. Lastly, I wanted to spend a minute talking about positive Boolean naming. Booleans spend their whole life being either true or false. They're rather good at it. They can flip back and forth at will. They learn to do so at an early age. There's only one way that they switch back and forth. That is with the not operator. Unfortunately for lowly programmers whose name is not Gilmore, their pathetic human brains don't do well with the constant knotting back and forth between varying states of 1 and 0-ness. The human brain is not good at processing double, triple, or quadruple negatives. Take the following code, for example. It's very easy for mere mortals to comprehend the evaluation of the isConnected property. With a modicum of programming experience, we easily process the next line, which is our first knotted expression, not is connected, or, oh, wait, that doesn't say not is connected. It says is not is disconnected. So that means we're connected, right? Yeah, I think so. Hold up. What about the third one? Is not disconnected? Why, that's just a rewording of the one above, isn't it? But then if we want to flip it, we get not is not disconnected. A flagrant attempt to confuse junior developers at the expense of code quality, no doubt. Surely nobody wants to bend their brain enough to figure out what that means. And then we have that last one, with a double not to cancel out the existing not in the word is not disconnected. But ask yourself at each step, is this connected? We're prone to confusion or error anytime we use a negative Boolean name, or anytime we invert it with a not operation. What do I mean by positive names? The word is connected is a positive name. The word is disconnected is a negative name. The word not connected is a negative name. The word not disconnected is a double negative. The idea here is to make the Boolean names positive in the first place, so that if we have to invert them, we only have to process a single not in our brain. If it starts out as a negative Boolean name, a single not immediately turns it into a double negative right off the bat. Further negation only compounds it. So not is connected is fine. Not is disconnected is immediately confusing. See how that works? So be sure to use positive Boolean names whenever you name a Boolean variable, parameter, property, or function.